is a video on how to use the Agilent 7700 ICPMS for the University of Cincinnati 3030L Analytical Instrumental Lab. So the first thing you need to do when you use this instrument is turn on the gases. We have helium here, so you just have to twist it to the left, and argon, which is the main source for the plasma. We then have to turn on the chiller, which keeps the instrument cool. It's a simple switch. The next thing we have to do is put on the tubing. The yellowish one here is the waste tubing. You need to make sure that it feels nice and round. If it's flat, it will not work. So you can see here the peri pump turns counterclockwise. So we're going to insert this into the peri pump so that the waste will come out of the instrument, around the peri pump, and out down to the waste bottle. Do the same thing with the sample tubing. Make sure it's round. Put it through the peri pump. So now it's going to come from the autosampler, around the peri pump, and into the instrument. Then want to lock the peri pump. So this is the autosampler that we'll be using. You want to be sure to take off the cover. Take off the covers of the solutions. The first bottle here is DDI water. You want to be sure that that's full. The second solution is 2% nitric acid. You also want to be sure that's full. This here is called the rinse port or home for the autosampler. Position 1, 2, and 3. And then you'll see that the autosampler vials have numbers associated with them as well. We also have cleaning bottles. This is the clean water, so you want to be sure this is full before you run. And this is the dirty water, so you want to be sure to empty this when it's full. This is just supply water for the rinse port. Now we can open up the software, ICPMS Instrument Control. You want to click on Instrument Control, and you'll see it's initializing. Here you can see the ICPMS, the autosampler, and these are the different components that are inside the instrument. To turn it on, click the small black arrow next to plasma and click plasma on. You want to be sure that this box is unchecked. It says execute configured ignition sequence. We do not need that for this lab. So we just click OK. You'll see that this square turned from orange to green. Now that it's flashing green, that means that the instrument is preparing to turn on. So after you notice that this green button is flashing, which means the instrument is preparing to turn on, we need to make sure that the needle or the probe on the autosampler is put into DDI water. So we just click on autosampler, the big button here, and you'll see this looks like the autosampler. We're going to click bottle 1, since that's where our DDI water is, and then just click go to. So then the probe moves to the DDI water bottle and lowers itself. As soon as the instrument starts, the peri pump will start turning, so we'll have water going into the system. Okay, so now you've waited 20 minutes for the instrument to warm up, and the probe is in DDI water, so now we have to tune the instrument. So you have to tune every single time before you run. I put a small amount of tune solution in a vial here, and I'm going to put it in position 3. Now I'm going to move the probe to position 3, clicking on the big autosampler button, click 3, go to. While I'm waiting for the solution to get into the instrument, the first thing that I'm going to tune is the torch axis. So on the plasma picture here, I'm going to left click, and I'm going to click torch axis setting. Now you'll just have to wait about maybe 30 to 60 seconds, and what you'll see is that the air bubble is going to travel through the peri-pump tubing and into the instrument. So you can see there's an air bubble here that's passing through the tubing, and it's almost to the instrument. When the solution enters the plasma, you want to wait about 20 to 30 seconds, and that's needed for the plasma to stabilize before you collect any data. So now that the solution's in, I'm just going to wait 20 seconds. I just click Run Torch Axis Auto Setting. So what the instrument is doing here is it's adjusting the height and the horizontal position of the torch so that we have the optimum amount of signal. So after it automatically tunes the torch axis setting, you can see that it's going to clean the probe first in the rinse port. Okay, now we're going to make your tune for your batch. So for this instrument, your method and your sequence and all the parameters you need for the instrument will be in what's called a batch. To create a new batch, we click on the black arrow next to batch, and we say new batch folder. Here you're going to create from an existing batch. You're going to click in the data folder 3030L Spring 2015. This is where it's going to save your batch. So here where it says create from existing batch, you need to select which batch you're going to use. Go into the 3030L Spring 2015. You're going to create your batch from 3030L ICPMS experiment. Click on that and click open. It's going to ask what you want to import. You can check off all of them. Click OK. Now we have to put in your batch name. So we ask that you start with the date and then your initials. That way everyone has a different data file. So you can just pick one person in your lab group and use their initials. So today is January 14th, 011415. I'm going to do underscore if you want, and my initials, AMD. So now it's going to be saved in the 3030L Spring 2015 folder. Click Create. So now all of these tabs are your batch. So the first thing we need to do is go into the data analysis method. If you click that, actually before we do that, sorry, we're going to be sure that the probe is in DDI water while you're working on this. So we're going to click Auto Sampler 1, Go to. Okay. In your batch, the first thing you want to go through is your data analysis method. So the tabs Basic Information, Analyte, Full Quant. If you click on Analyte, you can see we have germanium and arsenic. Germanium is our internal standard, arsenic is our analyte. If you click on Full Quant, this is where you put in your levels, your concentrations for your calibration curve. So this is all in ppb. So for this example, I have 7 levels, the first one being 0, the blank, 1, 5, 10, 25, 50, 100 ppb. You want to make sure that this is correct before you go on. The next thing is the sample list. Here I've just given some examples. What I'm going to do is I'm going to delete all of this and just start fresh. You can highlight all of them. If you right click, you can delete all the lines. The first 2 samples that you want are cal blank, and then the next samples are going to be cal standard. If you highlight and scroll down and right click, you can do fill down. After your cal standards, you're going to run your samples. You want to put in your sample name next. So, for example, the first one, 0 ppb A, 0 ppb B, since I have 2 different blanks. Then I have 1 ppb, 5 ppb, 10 ppb, etc. Then you want to put in the vial number. So if you click here, you can see the auto sampler vials here. So you want to be sure that you put the correct vial in the correct spot. If you happen to put all of your samples in a row, say you start with 60 and go through 78 or something, you can just scroll down and do fill down. You want to double check that the vial here corresponds to the auto sampler. After that, you want to do the file name. So here it's going to be your batch name followed by 01, 02, etc. So 01, 14, 15, AMD 01. And you'll see there's a .d after that, so these are going to be your data files. And then I'll just fill down. The last thing you want to do is your levels. So your calibration blank is going to be level 1, and then corresponding levels for your calibration curve. If you can't remember what your levels were, you can always go back to Data Analysis Method, the Full Quant tab, and see the different levels here. Once you finish your sample list, you go to Acquisition Method. You're going to go to the Tune window. This is where we're going to tune the instrument. So one thing that might be helpful, since you have to wait 20 minutes before you tune the instrument, you can turn on the instrument, then go through and make sure you have your data analysis method all set, make your whole sample list, maybe even fill the vials and put them in the auto sampler, and then tune right before you run. So again, we click on Acquisition Method, Tune. You'll see here we have 2 different tunes because we're using it in no gas mode and helium mode. So you want to be sure no gas is selected. I'm going to move the auto sampler to vial 3, which is my tune solution. And again, I'm going to wait for the air bubble to go through and then wait an additional 20 seconds for it to stabilize.
The first tune we had was with helium
You're going to do no gas first and then
Oh,
helium.
Oh, okay. So we haven't actually tuned it yet.
It's probably the name of this video. Okay, so now the tuned solution is in the instrument, and we've waited 20 seconds for it to stabilize. The first thing you want to do is click Send to ICPMS. This will send all of the parameters to the ICPMS. Now you want to click Start Signal Monitoring. It asks, confirm the probe is in the tuned solution. Click OK. So you'll see right now it's collecting data in real time, and these are the masses that are in the tuned solution, 59, 89, 205. One thing you want to note, 75 is not in the tuned solution, but it is the analyte that you're looking at. So you can see the counts are extremely low. So once you've waited about this long, you can say stop signal monitoring. You want to check that the numbers for 59 are about 20,000, 89 should be about 30,000, and 205 should be about 20,000. If the numbers seem like they're very off, find your TA and we'll try to retune the instrument. For 156/40 is the oxides, that should be below 2%, and 70/140 is double charge, that should be below 4%. So again, if the numbers do not seem like they should be, the numbers are weird, just find your TA and we'll try to retune the instrument. Now you want to click on the helium tab and you want to do the same thing. So we want to say send to ICPMS. So now the instrument knows it's going to turn on helium since we're in helium mode. And then you want to click Start Signal Monitoring. And then click OK. So we let the instrument collect data for a little while. Then we'll click Stop Signal Monitoring. So when we're in helium mode, you'll notice that the counts are lower. That's okay. So for 59, we should get about 9,000. 89 should be about 12,500. And for 205, we should get about 18,000. For the 70/140, for the double charged, it should be below 3%. And for 156/140, it should be below 1%. Again, you'll see we included 75 here since that's what you'll be analyzing. And you can see there's barely any counts. So this looks like a good tune. So now what we're going to do is click Save Batch. So now that you've tuned, the last thing you want to do is you want to rinse the probe before you start running. So click Auto Sampler, click Rinse Port, Go To. You want to take your tuned solution vial and dispose of it according to the lab protocol. Now click Auto Sampler and you want to go to Vial 1 and click Go To. You can double check your data analysis method, full quant, to be sure you have the correct levels. Double check your sample list. I've made an abbreviated sample list here. You want to be sure you have the correct vial, the sample name, your file name, your levels, your sample type. The last thing you want to do is click Save Batch, and then you need to add it to the queue, which will tell the instrument what is coming up next. So now this brings us to the queue window. You can also get there by just clicking the big button Queue. And you can see now it's running my batch. and you can see which sample it's starting with. You can also watch the data collection in real time. It will also open up the Mass Analyzer software, which is for the data analysis. So what you'll see is after it collects data, it'll start filling in the lines here, and it will start plotting your calibration curve according to what you put into the software. So after the instrument has collected your data, you'll see it constructs a calibration curve here. And you can see here all of the concentrations, counts per second, etc. The only thing that you really need to do is if there's an outlier, say there was a point that was way out here that was really not on your calibration curve, you can click that point and it will take it off the calibration curve. Then you just place the cursor over the chart, right click, export table. You're going to save this. The desktop has the folder for the spring 2015 section. You want to save this the same name, 011415_AMD, but here you want to call it raw ICP data. Then click save. That way you have a copy on the computer, and then you can save this to a USB. From here, you can manipulate the data so that you can then do your dilution calculations to get the actual concentration in your sample. When your analysis is finished, be sure to turn off the instrument. The first thing you want to do is make sure that the autosampler probe is back in the home position. So click autosampler, click home, go to. You want to be sure to cover the solutions. Dispose of your samples in the acid waste container. You do not want to put these down the sink because they contain 2% acid. Put the top back on. Then here, you click on the small black arrow next to plasma. Plasma off. Click yes. Then you can undo the peri pump tubing. You just disconnect it like that. Turn off the chiller. Close the argon. And close the helium. Then you're done.